Okay, so I'm going to show you how to derive the equation y equals mx plus b, which is a standard equation for a linear function, and we're going to use similar triangles and a dilation. So let's look at the specific graph first, then we'll get to the general case later. So here, our initial value is 2, and the slope, which is the other part of a function, or the rate of change, here's another integer point. So we'll draw a triangle, and it goes up 2 and right 3. So the rate of change is 2/3. I'll put that over here. Okay, now remember, all of the points on this line have the same rate of change, 2/3. So I'm going to draw another triangle. This is going to be a dilation. Okay, so now I'm going to dilate this triangle with a scale factor that we don't know necessarily. I'm just going to create another point, xy. Extend this line out. Okay, so here's our new point, xy. And we don't know what the values are necessarily, but we know that the rate of change has to be 2 to 3. So the distance here is y up, and it's x from left to right. Now we want to figure out this side of the triangle, the height of the triangle, so we can go ahead and compare using proportions. Okay, now I don't know how far this is yet, but I know the total height is y, and this initial amount is 2. So if I want to find this height of the triangle right here, it's going to be the y, which is here, but then take away the 2, which is down here, and that'll leave this piece of the triangle left over, or the height. So it'll be y minus 2 is the height of this triangle. Okay, now let's do a proportion. Now the rate of change we know is 2 to 3, and then for this other triangle, it's y minus 2 to x, because the y minus 2 is the height of the triangle, and the x is the change along the horizontal. Okay, so now we have a general proportion that represents every point on this particular line. So I'm going to cross multiply the proportion and simplify it and get it into an equation form where y is by itself, or the output's by itself. So cross multiply, 2 times x is 2x. That's going to equal 3 times the y and 3 times the negative 2. So it's 3 times y minus 2 in parentheses like that. Then we're going to have to distribute the 3. So it's going to be 2x equals 3 times y plus 3 times negative 2, which is negative 6. So minus 6 here. Okay, now I want the y by itself, so I'm going to add 6 to both sides. So 2x plus 6 equals 3y. Now I want the y by itself, so I'm going to divide everything by 3. Divide by 3 here, here, here. Now 2x divided by 3, that can be rewritten as 2/3 x. And then plus 6 divided by 3, which is 2, equals 3y divided by 3. The 3's reduce out to make 1, and you just have equals y. So I have 2/3 x plus 2 equals y. I want to reverse it so the y is first. So I'm going to switch sides here. Y equals 2/3 x plus 2. So here is the equation for that line. And I derived it using similar triangles and dilations. Now let's take a look at the generic case. Here's a generic linear function. The initial value is b, so the point here is 0b. And we'll do a unitized rate of change. m to 1. Now we'll do another triangle. So this other triangle is to the point xy, which is another point on this line, and any point on this line has to fit the ratio of m to 1, the same rate of change, because that triangle dilates, and that's what creates all the other points. Okay, so we know we have x here and y here. We need to figure out this measure of the triangle. We're creating a proportion m to 1 equals something to something for this other triangle. And we know the x is here. But what is this distance right here? Well, we know that the distance down below to the initial value from 0 to b is b. And we know y is the total distance here also. So this part is actually y minus b, because you take this whole distance y and you subtract b from it. So you're comparing y minus b and then to x. So this is a proportion for any linear function. Now let's cross multiply and solve this guy, write it in function form. So 1 times y minus b is just y minus b. And that equals m times x, which is mx. Now I'm going to add b to both sides. So y equals mx plus b. So this is the linear function in general form, and here is how we got it. We used similar triangles and dilated.